Hi, I'm Jessica with 3DS Technologies. Welcome to the full training course for SOP 14, operating the Leica RTC500 and 700 laser scanners. Over the next 15 minutes, we'll cover the platform, dispatch rules, field procedure, the complete traverse workflow, data custody, registration handoff, maintenance, and troubleshooting. One warning before we start. This is Revision 0, a draft for technical review. Do not sign off client deliverables against these tolerances without engineering review. This SOP exists to do three things: produce repeatable survey-grade point clouds, give the office an audible chain of custody, and guarantee raw data is never lost. It applies to all 3D scanning work with either unit in every environment. Registration technique, scan-to-BIM production, and client-site safety rules are out of scope. Where documents conflict, precedence goes. Client-site safety rules first, then the Leica user manual, then the signed project scope, then this SOP. Report every conflict to the document owner. Some vocabulary. A setup is one scanner occupation. It produces one full dome scan, 360 by 300 degrees, plus optional target scans, area scans, and imagery. A target scan is a small, high-density scan of a single target, used to fix the target's center precisely. It is what makes total station workflows possible on this platform. Albedo means surface reflectivity. Range specifications are always quoted against an albedo figure and are meaningless without one. Dark concrete and wet steel are low albedo. VIS, the visual inertial system, tracks the scanner as you carry it between setups, giving automatic in-field pre-registration without targets. We'll come back to its rules. And a manifest is a file listing every transferred file with its size and hash, the evidence that a copy is complete and bit for bit correct. Remember that word. Every job has defined roles. The scan technician executes the field sections and the field log. The party chief owns the control network, the traverse design, and signs the traverse record. The registration technician verifies data integrity, rejects incomplete jobs, and is the only person who releases a scanner for wiping. The equipment custodian owns batteries, firmware. LiveLink creates a role that didn't exist before: the scanning coordinator. Somebody in the office watches the job come in live and intervenes, while intervention is still free. On multi-scanner jobs, the coordinator stops two crews scanning the same bay and can run floor flatness or clearance checks while the crew is still on the ground. Now, the platform itself, the RTC series, is not a refresh. It's a ground-up consolidation of two product families you may already know. The RTC360 was fast, agile, and targetless, but limited in range. The ScanStation P-Series was survey-grade and long-range, but heavy. Historically, you chose speed or rigor. The RTC series collapses that choice. The 500 and 700 are the same physical machine. An operator trained on one is trained on the other. The shared architecture. 5.5 kilograms, IP55, -20 to +50 Celsius, time of flight ranging with waveform digitizing, and an invisible Class 1 laser. Angular accuracy is 10 arcseconds across the series. One briefing slide says 18, and it is wrong. Range accuracy, 1.2 millimeters plus 10 parts per million. Range noise, 0.2 at 10 meters. Imaging comes from a 6-camera, 72-megapixel HDR array, 432 megapixels raw, tone mapped to a 174-megapixel spherical image in about 30 seconds. You drive it from a 4.3-inch touchscreen or Cyclone Field 360 on a tablet. Inside, 512 gigabytes of storage and a USB-C data port. Where the tiers differ is reach. The 500 ranges 130 meters at 8% albedo. The 700, 270 meters at just 3.5%. Read that carefully. 270 meters against a surface reflecting 3.5% of light. That is the single most operationally significant number on this platform. Resolution steps at 10 meters run from 25 millimeters down to 3 on the 500. The 700 adds 1.6 plus a 0.8 millimeter area scan mode. A medium 6 millimeter dome plus imaging takes about a minute and a half. High takes 2. Super high on the 700 takes nearly 7 minutes a setup. Budget your day accordingly. Tilt compensation is IMU-based and self-calibrating, 3 arc seconds when level within 10 degrees. The instrument also runs a 13-second automatic self-calibration. No targets, no lab downtime. The tiers are separated largely by software licensing, not hardware. Before declining traverse work or renting a unit, ask Leica whether our 500 can be licensed up. That question is still open. Here's the dispatch rule. If the job requires a traverse, it requires an RTC700. No exceptions, and no workaround on the 500. Interior BIM, MEP, and floor flatness, send the 500. Corridors, tunnels, control networks, long sightlines, dark or wet steel, and inspection-grade detail, that is 700 territory. The 500's only geodetic workflow is resection from targets. It cannot occupy a known point with a known backsite, and it cannot propagate control down a corridor. Before anyone leaves the yard, the office does its homework. First, confirm the deliverable, the accuracy, and whether the job is georeferenced or local, in writing. Convert the control to CSV or text, then sanity check it yourself. Plot it. A transposed northing, a meters feet mix-up, or a stale datum will not be caught by the software and will destroy the job. Plan the setup layout on a site plan, design any traverse legs in advance, and confirm the model dispatched matches the job. Version currency matters. Field 360 version 7 is the minimum, and import requires Cyclone Register 360 Plus 2026.1 or higher. Never update firmware on the morning of a mobilization. Charge all 4 batteries. Check both field SSDs are present, formatted, empty, and labeled. And if you're traversing, verify the tribrac plummet is in adjustment before you leave. The standard kit, scanner in its transport container, 4 charged batteries, charger, AC supply, rain cover, heavy tripod, tribrac and adapter, targets, tablet, 2 SSDs, 2 rated cables, and the forms. Pairing is by QR code now. Power the scanner, open connectivity settings, and scan the code from Field 360. In a multi-scanner environment, it's the only sane way to connect. Finish with a function check. Boot, touchscreen, tablet connection, 1 throwaway scan, delete it. 5 minutes in the yard saves a wasted mobilization. On-site, walk the job against the plan before you set anything up. Photograph obstructions, note the light, and plan your direction of travel. At each station, plant the tripod firm, mount and lock the scanner, and level within 10 degrees. On soft ground, seat the legs properly. A settling tripod smears the cloud. Now the most important physics in this manual. Vertical error equals range times the tangent of tilt error. Inside 10 degrees, the compensator holds 3 arc seconds, under 2 millimeters at 130 meters. Outside 10 degrees, the compensator degrades to 1 arc minute, nearly 38 millimeters at range, roughly 78 at full 700 reach, 60 times worse. And here's the trap. Everything downstream looks completely normal. The cloud renders beautifully, the residuals look tight, and your elevations are wrong by centimeters. Level every setup. Choose resolution for the distance to the thing that matters, not the room you're standing in. Point spacing quoted at 10 meters doubles at 20 and quadruples at 40. 6 millimeters is the 3DS default, 3 millimeters for congested MF. 1.6 and area scans are for high-value detail. At nearly 7 minutes a setup, they eat the schedule on routine coverage. Start the scan, move away, and stay out of the field of view. And don't walk through the camera sweep. You will be baked into the panorama. Review every setup on the tablet. Shadows behind large equipment, glass and mirror artifacts, water, and any zone the client specifically asked for. Drop a geotag for anything the office needs to know. Unreachable areas, obstructions, discrepancies against the drawing. 20 seconds in the field saves a return visit. Between setups, VIS has rules, and they are not optional. Carry the scanner upright by the handle, walk a normal path at a normal pace, keep the lens path clear, and don't power down. If tracking is lost, Field 360 will tell you. Do not ignore it. Walk back into the previous setup's space, or accept a manual link and note it on the field log. 2 linking methods exist, and they cannot be mixed within the same pair of scans, cloud to cloud by default, or target to target with a minimum of 3 targets per scan. Long symmetrical corridors are where cloud to cloud lies to you. Every bay looks identical, and the algorithm happily produces a confident, tight, completely wrong link. Use targets there. Where site connectivity permits, activate LiveLink. Each setup streams to the cloud on completion, and the coordinator calls out coverage gaps while the crew is still on site. But LiveLink is a preview stream, not the deliverable. The full resolution raw data stays on the scanner and must still come off by hand. The cloud is not a backup. Before leaving site, walk the coverage against the plan, confirm every geotag is placed, and delete nothing. Nothing comes off that scanner until the offload is verified. Now the flagship workflow, the Traverse. This is 700 territory, and it's what separates a survey from a very expensive sketch. One blocking caveat first. Leica's own product team suggested Traverse might not ship in the initial release, while the datasheet lists it as delivered. Confirm the workflow is present on the actual unit before scoping a Traverse job. A Traverse carries known coordinates from a known point through your new stations to another known point. Each station is oriented to a backsite and measures the next foresight. Cloud-to-cloud and VIS make a point cloud look continuous, but they accumulate drift with no independent check. A Traverse gives you coordinates and a measured misclosure that proves the work. Plan it in the office. Minimum 2 known points, one to start on, one to close on. Prefer a closed link between independent points. A loop back to the start won't detect a bad starting orientation. Design the legs around the target measurement limit. 75 meters, that's the constraint, not the 270 scan range. Keep legs similar in length and minimize the station count. And set the acceptance tolerance before you go, including the infield backsite reject threshold. Deciding what's acceptable after you see the misclosure is not surveying. Targets. Black and white, 4.5 or 6 inch, 6 on longer legs. Force centered on tribrax over the mark, face square to the instrument. Never taped to a wall, never handheld. Measure and record instrument and target heights at every station as you measure them, not from memory afterwards. A single transposed digit is the classic vertical bust. The procedure itself is a rhythm, and I want you to memorize it. Occupy, backsite, check, scan, foresight, leapfrog. Let's walk through it. Create the job with the survey workflow enabled and the control file attached. Occupy the first known point. Center and level with the tribrac, take your time. This error propagates down the entire run, and record the instrument height. Orient to the backsite, a forced centered target on the known point. Run a dedicated target scan, then the target fit. Then review the residual. This is your first checkpoint. If the backsite residual is out of tolerance, stop, do not scan. Check the heights, check the target is square, check you picked the right control point. Check the tribrac. Accept the orientation, run the full dome scan at job resolution, place your geotags, then execute a target scan on the foresight and name it unambiguously. Then the leapfrog, the mechanical heart of the Traverse. Scanner and target swap between tribracs. The tribracs never move, no recentering, no new centering error. If you instead break down the tripod and set it back up, you've introduced fresh centering error at every single station and thrown away the accuracy you came for. Advance station by station with the same rhythm. A station that skips the check step is a station whose error won't surface until closure, after the crew has demobilized. A Traverse that doesn't close on a known point is not a Traverse. It's an unverified guess with a lot of setups in it. Close on a second independent known point, and the difference from truth is your misclosure. Compute all three: angular misclosure, linear misclosure, and the ratio, linear over total traverse length, expressed 1 to n. That ratio is the headline number that goes in the report. Vertical misclosure deserves separate attention. If horizontal closes beautifully and vertical doesn't, go check your height notes before you blame the scanner. It is almost never the instrument. Within tolerance, adjust, distribute the error, and lock the positions. Be confident before you lock. Out of tolerance, do not adjust it away. Adjustment smears a blunder across every station and makes it invisible. When a Traverse won't close, work the list in order. The control, your notes, point identity, per station residuals, the tribracs, a moved tripod, and only then suspect the instrument. Remeasure the suspect leg, not the whole run. Data custody. The governing rule of this entire manual: nothing is deleted from the scanner until it is verified, not copied, verified on two independent media. Know where data lives. The scanner holds the master copy. The tablet holds previews. The cloud holds previews. Only the two field SSDs and the server count as copies. Buy drives to spec. Rugged external NVMe, USB 3.2 Gen 2, 2 terabytes minimum, 2 per crew, physically labeled primary and backup. Thumb drives fail, and they fail silently. Offload on site before demobilizing. Put the scanner on mains power, run the export, don't touch anything while it runs, wait for the completion message, and eject safely from the scanner interface. Copy the backup drive from the scanner, not from the primary. Cloning drive to drive copies any corruption you just introduced, and hands you two identical broken copies with matching hashes. Verify in 3 levels. Level 1, on-site. The job folder exists. The setup count matches the field log, the count you wrote down, not what the software reports, and there are no 0-byte files. Level 2 is authoritative. Generate SH256 manifests of both drives and compare them. Identical manifests from 2 independent reads means the data is bit for bit correct. Save both files. They are the audit record. Level 3. At ingest. A verifying copy to the server. Rerun the manifest against the server copy. Then import and confirm setup count, imagery, targets, and a clean bundle. In transit, the 2 drives travel separately. Primary in the equipment case, backup on the technician or in a second vehicle. 2 drives in the same bag is 1 drive. The scanner may be wiped only when every condition holds. Level 2 manifests identical. Level 3 ingest verified, and the transfer record signed by the registration technician. The person who did the copy is not the person who confirms it. Nobody wipes a scanner in the field. Nobody wipes a scanner to make room mid-job without authorization and a verified offload. That 512 gigabytes is a buffer, not a bin. The registration technician starts only with verified raw data, the traverse record with misclosure figures, the control file actually used in the field, and the geotags and notes. If anything is missing, the job goes back to the field. It does not get worked around. The software chain: Field 360 for capture, Register 360 Plus for registration, Infinity for traverse computation, GeoCloud for collaboration, and CloudWorks, streaming into Revit, AutoCAD, and Navisworks. Every registered job produces a registration report. Every traversed job also ships a traverse report with the misclosure figures. Both go to the client. A point cloud without an accuracy statement is a picture, not a survey. Daily care. The scanner travels in its container, not on a seat, not in a tote. Inspect the front window before the first setup and clean it only per the manual. The wrong solvent is a service center repair. If a scanner is dropped, it's out of service until checked. Check the shock sensor and report it. Nobody gets in trouble for reporting a drop. People get in trouble for hiding one and delivering bad data. Batteries. Store at partial charge, rotate onto charge nightly, and keep spares warm in cold weather. Capacity drops hard below freezing. Retire anything swollen or fading. Don't nurse it along. Self-calibration runs continuously, but it does not replace Leica's service certificate. Many client sites require a current one as a condition of entry. And retire field SSDs on a defined schedule. They fail without warning. Troubleshooting favorites. Tablet won't connect. Use the QR code and restart the app before the scanner. Cloud to cloud won't hold. Switch to targets. Elevation's wrong, but the cloud looks perfect. You leveled outside 10 degrees. Scanner can't see the SSD. Suspect the cable first. Charge-only USB-C cables are everywhere. A checksum mismatch means stop. Re-offload to a third drive from the scanner. Identify the bad drive and quarantine it. 3 records are mandatory on every job: the field log, the traverse record, and the data transfer record. All 3 are retained in the job folder for the life of the project archive. Finally, this manual admits its gaps. Every verify tag must be reconciled against the official Leica manual before revision 1, and unsourced marketing numbers are never quoted to a client. Argue from the specifications. Because every competitor can buy the same scanner. What they can't buy is a crew that levels every setup, closes every traverse, and never wipes before the checksum matches. The performance boundary is no longer defined by the hardware you carry. It is defined by the workflow you execute. That's the whole manual. Thanks for watching. Now go run it.